I'd also like to offer my welcome to all of you attending, especially those of you joining us from outside the US. Thanks for being here. Today's topic is software automation, so let's get started. Well, why do we consider automation? And I'm going to broaden the question a little bit so that it's not just software. Let's just talk about automation in general to start with. Look at this. We've got, on the left, a beautifully kept vertical storage rack. In fact, this picture could be an advertisement or advertising for somebody who makes racks like this. It's really well kept. Everything about it looks right. But people will opt for automating their storage and retrieval system for some reasons, right? And with automatic storage and retrieval, you look at this and you say, well, maybe a Jeep driver is going back and forth, getting material and then taking material back to the rack to support 3 or 4 or 5 machines possibly. And what happens if multiple machines go down at the same time? Well, at that point, you'd wish you had an automatic storage and retrieval system near your machine where an operator can just deliver the material to himself. So that's one advantage in a system like this. Also, here's a laser operator, probably familiar to many of you folks. You've got a laser operator who's loading material onto a laser, and with that, if he gets tied up, if he has to work on parts that they don't come out exactly as you hope, maybe he's got to do a little grinding some tabs off or something like that, has to leave and go to the restroom. What happens is at some point the machine may go down, and with an automatic storage and retrieval system that not only brings material down but loads a machine, in that case, as you know, the laser machine then establishes the cycle time for your parts and not an operator. So there are throughput advantages here, not to mention what might happen on off shifts if you can run lights out. Well, on the left, we got a couple of operators here. They're feeding a press brake, and with this is not only an ergonomics thing, but also an item where you've got 2 people making one part. So in a large press brake operation that you can automate with a robot, you not only look at the labor savings of one person, maybe 2. Okay. On the right, we've got the Cincinnati RoboForm product for handling small parts. It's a smaller machine, but we also do robotic integration for larger ones as well. But some of you have even done this type of automation. Well, the guy on the left here with welding, he's a great welder, right? He's the guy that you want when you've got the toughest parts, but he's also got to do simple parts as well. And wouldn't it be nice to offload the simple parts onto some sort of robotic system and then let him do the tough ones, essentially by exception, doing the tough parts by exception. That's one of the things that automation allows as well. And here's another example. Here's a guy painting a part that very easily could be automated. Also, from a safety and ergonomic standpoint, he's not really dressed real well for doing the painting. I don't know if you can tell, but down around his wrists and his hands, things are starting to turn white here with him. So from a safety standpoint and also from, a general automation standpoint, painting is a good example. And probably many of you, if you don't have finishing in your shops, can do this with a shop that's doing this type of automation outside. So you can see there are a lot of types of automation that can really help. And I guess this brings us to a poll here, a polling question. Nikki, I'll turn this over to you, okay?
Okay, let me launch it. So the first polling question is, have you purchased any kind of automation in the last 2 years? Please feel free to answer yes or no.
These polls, I enjoy these. These are kind of fun because it allows us to share back with all of you to let you get a feel for those that are attending and how they might answer something like this.
All right, I'll just leave it for a few more seconds. All right, I'm going to go ahead and end the poll. And here are the results. Looks like 24% of you said yes, and 76% of you said no.
Interesting. Well, that's quite a good chunk of you, because that's automation is quite a big investment, and to have 1/4 of you already have done this in the last 2 years, that's really significant. Well, here I'll just advance it to the next one. Okay, so to kind of summarize here, why do we consider automation? Let's just talk through some of the things. Increased throughput, we mentioned that. Lack of skilled workers, we hear that all the time as a justification for automation. In fact, we probably beat that horse until it's completely dead. Consistent production and consistent quality. A good example of consistent quality, whether you like them or not, McDonald's hamburgers, wherever you go, is consistent. And automation, in a lot of ways, is the same. If you can make a quality process that's automated, then that consistent quality continues. And the opposite is true. I remember a number of years ago, I went into a shop and was with a customer, and behind his desk in his office, he had a little poster up, and it said, automation poorly applied only allows you to create scrap more productively. And that's what we don't want to do. So if you can get a quality operation going with automation, it's really awesome. Also, standardized workflow. If you're not working to standardize your workflow, you're going to be. This is something that's beginning to happen more and more. And automation, or an automation project, grabs the workflow and forces that along with that automation project. So I think that's something that works kind of hand in hand. Certainly ergonomics and safety, and then scalability. That's an interesting thing, right? If you've got an automated process, it's working well, it's giving you the consistent production you want, it's giving you the consistent quality that you want, and then you need to expand your operation, you can scale it once, twice, 3 times as your company grows and expands, because it's something will really, really work for you. So scalability is a big issue. Also, naturally, it maximizes the benefit of your labor dollars. It's force multiplication for labor with automation. And then lastly, it improves your company image and morale. All right. And I do want to just mention, before I leave this slide, I want to mention something with the asterisk items here that were noted in the Fabricators Automation ebook survey. One of the things was, on the first 2 items there, everybody's heard about skilled workers and lack. Cincinnati Incorporated were in the same boat, right? But the interesting thing, among people that responded to the survey with the Fabricator Automation survey, in those first 2 answers, answer number 1 and answer number 2, they actually found that those that had bought automation and employed automation were doing it 2 times for every 1 time that they said that they bought automation for skilled workers. So throughput and decreased lead time was really significant, on a factor of 2 to 1 over the skilled workers. And then lastly, they were surprised about the last item on the list here, but almost everybody mentioned it, that purchasing automation really improved the company's image. And also, even though people had dragged their feet on the shop floor, it really improved the internal morale. The reason? Because people like to see when a company invests in itself, invests in its people. And that was something that was really interesting that came out in their ebook survey. Well, let's move over now and let's talk software automation. For those of you that are older, in fact, my parents were the World War II generation, everybody knew what this was, right? This was graffiti that was done by, American GIs in Europe, American GIs over in Asia. And though the American GIs were in the press quite a bit, and everybody was hearing about what was going on, individual GIs didn't want to be forgotten. So they had graffiti that they would place wherever they were. Well, I'm going to co-opt this graffiti. Instead of saying Kilroy was here, I'm going to say programming was here. So I want to point out that in this example, laser automation, it's great to move toward laser automation, but with it is going to carry a programming load. All right. Similarly with the press brake, okay, we can add robot tending to a press brake, but we're going to add a programming load to that as well. Similarly with painting, similarly with welding. And then finally, when it comes to data reporting, also the analysis of data and working through data, there's a data management load as well. So I want to point that out because we think often of, work consolidation, work simplification out on the shop floor. But if we bring it to the office, we're just moving it around. Okay. So software automation has a really big effect on trying to reduce all of that. So let's go to the next polling question here. Nikki, I'll turn it over to you.
All right. So polling question number 2. If you were to purchase software automation, what area would be considered first? Please feel free to select one of the options. I'll leave it up for just a few more seconds.
Oh, thanks. Yeah.
You bet. All right, I'm going to go ahead and end the poll. And here are the results. So it looks like 65% of you said press brake software, 25% of you said laser software, and 10% of you said welding software.
Oh, that's interesting. That's it. Yeah, I would have thought laser programming software would have been higher on the list, but that's good to know. Very cool. Here, let me go ahead. I'll advance the slide here. Okay, so software automation. Well, how is it different from machinery automation, and how is it similar, right? Well, here's the skinny. It's actually very similar. About the only thing that's different really is ergonomics and safety. And so it's very similar. And I'll just jump right over this and go to my next slide. So with software automation, how do you know if you have it? And what are really the keys to success in a fabrication operation? Well, it's really simple, guys. The way you know that you've got it is you can walk away from the software process and it keeps going. All right. It doesn't tie somebody to a computer screen all the time. So let's move on from that. And let's talk about the keys or the benefits of software automation in a fabrication shop. If we're really going to automate this, what we're really going to do is reduce the workload in areas that you have to do every day. Blank development and resizing, machine programming, inventory management, nesting, machine load balancing. What work goes on what machine? Quoting and estimating, finished work reporting, raw material ordering, and lastly, bringing all that data together so that we can reanalyze things and see if we're doing a right job. Okay. Now, I'm going to mention a story here. This is kind of an interesting thing about offline programming. This is going back about 10 years for me. Well, more than that, maybe about 15 years. I was in machine tool sales for a while, and I sold a machine to a guy, a press brake to a guy, actually up in Wisconsin. And I said, you really should consider programming that press brake offline rather than programming it at the machine, and explain to him the benefit, right? The benefit of doing that was that the press brake, it's now going to be going up and down, right? More often, making more parts, more throughput and everything. And I thought, oh, that's great. Came back in a couple months. He said he was going to do it. And I said, are you programming offline? Oh, yep, I'm programming offline. And I said, what do you think? And he goes, well, it's kind of what you said. He said, the machine, it's got much more throughput than I really ever thought. That's really great. But he goes, I got to tell you something. He said, by moving the programming from the break to moving the programming in the office, and these are dollars that he mentioned back then. He said, I went from, programming with a $15 an hour guy to programming with a $35 an hour guy. He goes, how's that good? He said, I took 2 steps forward, but I took 1 step back. And so my question is, does software automation have something to offer somebody like that? Well, he gave me a goal. He said, you know what? Offline, I want to create the same number of programs. They've all got to be created, right? And the programming dollars that I want to spend, if I move that offline, I don't want to spend any more for it. The program dollars must be the same or less, right? So by doing that, if we do a little calculation for him with his ratio, he needs to program to keep the dollars the same, to get the same number of programs. He needs to program in 15/35 of the time and 43% of the time. But he's got to do the same number of programs. So how do you do that, right? Well, that's where software automation comes in. And what I'd like to do is show you an example here with our Cincinnati BenSim Pro software that deals with batch programming. What you're going to see in this video, you're going to see us move from a source file of solid models to an output file of finished programs and setup sheets. And that's only if you want, right? But if you want to do setup sheets, they're made automatically. There's not much manual input. And with something like this, it's 50 to 75% successful. It's not 100% successful because there are difficult press brake parts that just can't be simulated to the same extent to what a really creative person is doing on the floor or whatever. So, 50 to 75% successful. But what that does is that leaves the programming for the program workload for the person working offline to be really about 25 to 50% of what it used to be to do those more difficult parts. So here, I'll go ahead and I'll play this video here, and I'll try to narrate a little bit about what's happening. So what's going on is we're going to the create a batch page on this, and we're just going to choose parts that we can make. And in this case, I'm just choosing 4 parts, but it could be the entire folder. It could be, it could be 100 parts. Okay. And then on that, we'll choose how we're going to execute it. Do we want to do it sequentially, or do we want to do multiple parts at one time? And I just did it sequentially. I'm also going to choose where these parts, or at least where the programs for the parts, and also where the setup sheets for these parts are going to go. I'm just putting them in a temp folder here. And then lastly, I'm going to say what method of tooling these parts. How are we going to do this? Are we going to go through all the tools? Are we going to go through suggested tools or whatever? In this case, I was just going through recommended tools on this. We give this batch a name, and then click execute. And what's going on now is for each part, it's just going through a 4-step process of finding tools, developing a sequence, making multiple stations across the press brake in the simulation phase if necessary, and then making the output for the code for the machine and for the setup sheet. And it's just jumping from one to the other. Okay. And in this little video clip, this takes, I don't know, a minute and a half, 2 minutes roughly for 4 parts. So, if we say 40 parts, then is 10 times that. We're talking 20 minutes for, I'm sorry, excuse me, we're talking about 40 minutes for 20 parts on that, or if we do, or if we do, 4 parts in 200 or 400 parts in 200 minutes, you can see that it's doing quite a lot of work in the background for us. And some of them will ultimately fail, and at that point we get a report on what those are. And then we can go back and use some of the automated features to help us essentially manually program those one by one. But it really reduces the workload then of a programmer. Now, in order to make this work, we have to have standardized rules for our tooling so that we can do just that. Okay, we can't air bend something to 1/10 of a material thickness inside radius or something like that, right? Okay, what you see here is we're opening up the setup sheet for one of those first parts that we made, the flat view, the form view, right? And then turn by turn instructions. See, all this was created for each of those 4 parts, as well as the code and the graphics that will run on the machine. And there they are right there. Okay. And let's also talk a little bit about the laser, right? With Cincinnati's Nesting Pro software. We can do a number of things, right? We can go from a solid model assembly, split the assembly apart, and program the laser and the brake from that. We can also trigger an order from an ERP output. If we're generating a CSV file, we can automatically populate that nest and have all that run for us in the background. And it doesn't have to be one nest. I mean, heck, we could populate a week's load of work from that ERP order. So there's some really neat things on that. So we start with a source file again, this time of solid models or flats or pre-programmed laser parts. We can mix and match with that. And if we're using a solid model, the Nesting Pro has a built-in unfolder in it to unfold the solid model into a flat based on how you would unfold it using bend deduction tables that you modify to your liking. And so we can nest all of those types at one time with that. Also, we take that, like we did with the press brake, to an output file of nests and programs, right? There's little or no manual input, and this is nearly 100% successful. The lasers are, and punches are a little bit simpler to program than the brakes on that. But here, I'll just go ahead and start the video that I put together on this. This one happens to start in SolidWorks because we're going to use an assembly. In fact, this was an assembly that we had used, I think, at Chicago at the Fab Tech last year. Just something I could grab onto. It was a stock car with a number of parts. And with this, you see, we can go over and split this apart. And when we do that, we instantly identify which are the sheet metal parts and which are not. In this case, they're all sheet metal parts. Also, we can map the material. In this case, it was stainless, but we can map the material for each of the parts in the assembly into our nest. So naturally we can mix and match materials in our export and then make nests accordingly. But you can see what's happening. Naturally, this is a video, but if it wasn't, I still wouldn't be touching it. It's running automatically and splitting everything apart into ready to nest parts. Also, by the way, you notice these have bend angles and inside radii on these. So these are not only ready for nesting, these are going to be ready as well for automated bending. And then here is our report file of what we split out of the assembly. And then we can just click on, at the bottom, start a daily job. And then what that will do is that launches these parts right into our nesting software. And that's launched automatically in the background. Here, I'll get rid of that. And then you can see all of the parts now have been given to us in nesting. We can come across and look at the order if we want. We can even edit it. What if we want to make 100 of these assemblies? We've got a multiplier here. We take 100 and click on the times button right there and see our quantities. If you notice, our quantities all changed to 100. And then we now click Auto All. What Auto All does is it checks all the DXFs to make sure that they've been made properly. And if they're not, it corrects the errors. And then also it applies the cutting conditions for this material for these parts. And they're ready to go. And now we just go ahead and run these. And what you see happening here is multiple nests of material being made, actually rather quickly. This was completed in 10 seconds, but here are all the nests to create 100 copies of that stock car assembly with all the parts. And then with that, then we can go ahead and create the NC code and we're ready to go. So that is something that we can do. And finally, if you want to do the very same thing from an ERP standpoint, you can send the script and all this will run in the background and then just put the programs in the receptacle of the output folder. So that's nesting. And then lastly, I just want to mention data reporting. With Cincinnati CyberDash, what we're doing is we're data mining our machines, sending that information to the Microsoft cloud, the Azure cloud. And then from there, we could take that data and give you password protected scoreboards and phone apps and all the things that go so that you can see your data and manage things on a day-to-day basis. Now, some people might have the question, well, that sounds great, but what if I have a third-party dashboard? Well, what we can do is we can do the very same kind of thing, but we can output data from the cloud through API calls to your third-party dashboard. If it's a dashboard that works with the cloud, we can go cloud to cloud and give that information over so that the Cincinnati machines report to your dashboard that has not just Cincinnati machines, but others at the same time. Similarly, you might say, we don't want anything to go to the cloud. We'd like things to stay within our walls. We just like the same data to come out via OPC UA, okay, the OPC UA format. And it's similar to your MT Connect. We can do that as well. So we can then not use the Cincinnati dashboard, but go to your device within your walls that can then make a dashboard as well, tying the Cincinnati machines in with a paint line, with welders and other devices that Cincinnati doesn't make. All right. So that's kind of a summary of how you could possibly tie the machines in. I want to give just a little commercial for CyberDash and just show these are the kind of outputs that you get for Cincinnati lasers. You get certainly a progress bar showing how the machine's been running during the day, a graphing showing how the machine's running over, the near term, maybe in the last week, okay, as well as fault codes and error codes that you might want to check when you're discussing with an operator. Remember, all this stuff can be on a scoreboard on your shop floor, so it can alert you to what you need to manage. But then when you show up at the workstation, you can actually use your smartphone and see these very same screens on your smartphone, and discuss with an operator a fault code that might be coming up more often than not, or why did the machine go down at a certain time or something like that. So you can do that. This is for the laser. The press brake screens look a little bit different. The first one's very similar with the progress bar. The second screen's kind of interesting here. what you're seeing is that for parts where you've got a history on those, today's graphing is the yellow, okay? And that's being graphed against the maximum rate that this part has ever run. That's the red line right here. And the minimum rate that this has ever run is the blue. The average is the green, okay? So it's good information to have a discussion with a supervisor or with an operator to say, this is how I see you're running it, versus historical data. And you can use that right now to manage. Also, in the background, you can't see this real well, but there's kind of a light green or light gray representation here in the background, and that's showing the accumulation of finished parts throughout the production run. And it's growing, right? So we've got that. And then finally, the fault codes that we had on the laser. Similarly, we can show you fault codes for the brake. And then lastly, it wouldn't be much of a data reporting system if we didn't give you good data that you could pour over time. And we can give you output data that is raw, that you can use for essentially an Excel manipulation that you can do. We've got one customer of ours that has around 30 press brakes tied in on a system like this. And their engineers have come up with their own operator evaluation method and program format where they use this data. But some people say, I don't have time to do that with Excel. What have you got that I can look at immediately? So we have pre-configured workbooks here that you can download the data and choose from a start date to a finish date, show all your press brakes, and each of those will show a graphing of the performance of that machine over time. And also you can sort by operator, you can sort by part, all kinds of different things like that. So I just want to mention that on the data gathering side, now the machines can be part of the process in supplying you with data that you can use now to make data-driven decisions. So to summarize, what we're all about with software automation is not really replacing the things that you do. We're just trying to do them more efficiently. We're trying to reduce the workload on the blank development and resizing, reduce the workload on machine programming by doing some automated batch type work. So you're only programming by exception. We have some inventory management tools that I didn't talk about. Certainly you saw nesting going directly from a solid model to creating a nest for 100 of those reps of that assembly, right? In less than 2 minutes. I mean, it's very, very quick, right? Machine load balancing, we have that with our scheduler product. Our nesting has quoting and estimating on that. So you can do your nests and spit out a quote for your customer right off the bat. And finished work reporting in the data management, we've got that as well. So I won't go through everything, but you can see there are a lot of things that we can do to help reduce your software workload or programming workload.